3.2, so we're skipping 3.1. So first, solving systems algebraically. So what is a system? When we have a system of equations, essentially it is where two graphs or two equations overlap. So if I had this graph, a system of equations, let's say if I drew a line right here, and let's say if we also have like an absolute value equation. So if these two equations, my answer to this system are these two locations where they cross. Now we're going to be solving just two linear. So if I have two linear, if this is my x and y axis, if I have two linear, it would be something like this and something like this. So this would be where they cross. So this is what we're solving for. Where do these two equations cross each other? I'm going to show you two different ways that you can solve these two equations. First, by substitution, and then by elimination. So what I'm doing for substitution, here are my two equations. I want to try to get one of these two equations so that it's only a variable by itself. So like right here, if this y has no number in front, I'm going to solve the second equation for y. So this equation would be equal to y equals negative 2x plus 10. So now once I have this one by itself, I can plug this into this y, to the other equation. You always have to make sure you're plugging into the other equation. So I'm going to have 3x plus 4. I have negative 2x plus 10 replaced for y equal to 12. So I'm going to distribute this 4 in. So I have 3x minus 8x plus 40 is equal to 12. So I can combine these two like terms. This is negative 5x plus 40 equals 12. Subtract my 40. Negative 5x would be equal to negative 28. So this is not going to be that nice of a number. Divided by negative 5. And I would get x is equal to 28 fifths. So now I have my x value. Now I can go back to this y equation right here. So then I can plug in my x value because I know my x value will be 28 fifths. Now, personally, I'm going to do this right in my graphing calculator. When I have fractions, I like to do it in my graphing calculator. I'm going to do 28 divided by 5. You could still also do your fraction key, plus 10. I should get a decimal. I'm going to go to math and change it to a fraction. So negative 6 fifths. So y is equal to negative 6 fifths. And if you leave like your answer just like this, you'll be wrong. Your answers should be an ordered pair. So x goes in my x spot, y goes in my y spot. And there you have it. This right here is my final answer. So for the second one, I want you to try to do it by yourself, but when you're solving this by substitution, you want to look at my different variables, and whichever one does not have a coefficient in front, so a coefficient would be in front being multiplied by the variable. So I want to solve this one for x. So if I solve this for x, that means I'm subtracting my 3y over. So now this goes in place of this x. So I want you to pause the video, try to attempt it yourself. Your answer should have been negative 5 halves for x and positive 5 halves for y. So now I want you to try to solve this one. So now, because we don't have the x and y, when we write it as an ordered pair, and your answer should be as an ordered pair, typically the letter that comes first in the alphabet goes in the x spot. So C comes first. Whatever you solve for C should go first. So I want you to try to solve this for C and F now. You should have got 30 for C and 120 for F. So that's by substitution. Now we have by elimination. So when we have elimination, we look at the equation up and down. So now this first one's going to be a little bit easier. Not a little bit. It is for sure going to be easier for elimination because our first objective is trying to get a coefficient, so a variable, with the coefficients that are the same but opposite. So right now, my 4x and negative 4x are the same but opposite of each other. So when that happens, that's your first step, is to trying to get them opposite of each other. You just have to add these two equations together. So when I'm looking to combining like terms, 4x plus a negative 4x, they cancel out to just be 0. 2y plus 3 will give me 5y. 9 plus 16 gives me 25. So the reason we want that is because that cancels out, so you should have just one variable to solve for now. So y is going to be equal to divide by 5, 5. So now I can plug this either into my first or second equation. It doesn't matter. So I have 4x plus 2, and then I plug 5 in for y is equal to 9. So 4x plus 10 is equal to 9. 4x would be equal to negative 1. Divided by 4, x is equal to negative 1/4. And I still write it as an ordered pair. So negative 1/4, 5. That's my final answer. I want you to try to do b by yourself right now. I can again just add these together because my y's are the same number but opposite, so positive, negative, so I can add them together. When I add them together, I get 3x plus 0y equals 12. I solved that, I get 4. I chose to plug it into the second equation, no reason, just because. And when I plug it into that second equation, I get y is 0. So my ordered pair is 4, 0. So what if, like this last one, we have coefficients that are not opposite of each other? So one thing you can do, and it will change depending on what the numbers are, you can multiply one or both equations by something so that they are opposites of each other. So I'm going to multiply this top equation by a negative. And if you look, we should get the same thing here because it looks like they're the same question. So this, if I multiply all of these by a negative, I would get this. Now, looking at these two equations, I can add them together. So I get a positive 6c will be equal to 180. And if I solve this, c is equal to 30, just like up here. So it's kind of taking out that step. So now if I plug 30 back into the equation, it doesn't matter for what. I'm just going to trust my work from before. It'd be 120. So that would be my answer for that one. Sometimes it will say solve this system by substitution or by elimination. If it doesn't say it, then you choose. You get to pick how you want to solve it. I'm going to solve one of these by substitution and one of them by elimination. I'm going to start with elimination, and then I want you to finish solving them. Now, one of the reasons I personally always like elimination, especially when there's coefficients in front of all three of these, I'm going to multiply this top equation by 3. I'm going to multiply this bottom equation by negative 2. So maybe you could guess, like, why did I pick those numbers? I'm picking these numbers so that I can make sure that my x's are going to be the same but opposite. When I do this, though, I have to make sure to multiply all three terms by 3 and all three terms by negative 2. So now looking at these two, I can add those two together. I want you actually to pause the video and try to do it yourself. You should have gotten the answer negative 2, 2. Here, when I add those together, I get 11. Divide by 11 is 2. I plugged it back in. I chose the first one. Now, you can choose if you want to pause the video and try to do this one by elimination again. I'm going to show you, though, how you could do it by substitution. Some people really like substitution. Go for it. I typically, when I have the choice, will always choose elimination. If I'm going to choose substitution here, I have to try to look at the variables to see which one I want to solve for. It doesn't look like any number is going to be super easy, so I'm just going to solve this one. Actually, I'm going to solve this one right here for x. So first I'm going to subtract over my 7. So I have 3x, subtract over my 7y plus 15, and now divide each by 3, and I get that x will be equal to, I'm going to put a little thing so you know, will be equal to negative 7/3 y plus 5. And the only reason I chose that is so that I could have at least one number without a fraction. So now I'm going to plug that x right into there. So I have 5, and now instead of writing x, I have negative 7/3 y plus 5, so everything that x is equal to, plus 2y is equal to negative 4. So I want you to try to solve this the rest of the way. You should have got negative 2/3. Now, the reason I don't always like to use substitutions is because I'm dealing with these fractions. So when I distribute here, it makes a fraction over here. So when I combine these like terms, you have to make sure to be careful. And you should have gotten negative 29/3. I also subtracted over the 25. That's where this negative 29 comes from. I multiply by the reciprocal. Either way, if you chose substitution, you should look through my work. If you chose elimination, your final answer should be negative 2, 3. Last two questions. You, again, can always choose how you want to solve this. I noticed that these two, I'm going to use elimination because they're already opposite each other. I'm going to multiply this one by 2. So this becomes negative 2x plus 2y is equal to negative 4. So I multiply the 2 by each one of these, and that's where this comes from. So now I can add these two together. So when I get this 2x plus a negative 2x will give me 0x. Negative 2y plus 2y would give me 0y. 0 plus a negative 4 is negative 4. So what I get here is 0 equals negative 4. If this happens, all of my variables cancel. This is a false statement. 0 is not equal to negative 4. So there is no solution. I want you to try to do the next one however you choose to do it, by substitution or elimination. Here I chose the elimination and I got 0 equals 0. This is a true statement. So here, all real numbers. So if all the variables cancels, either your answer would be no solution or all solution or infinite solution. And there you have it. Bing, bada, boom. Have a great day.